There we go, now it works. All right, so yesterday we looked at the relationship between marginal and total, specifically looking for that change in the total cost, which is your marginal. So short-run production refers to how the business makes decisions in real life. So we're going to have short-run and long-run. Long-run is really just a projection of what is possible in the future. So to define it specifically, short-run, you've got at least one fixed resource. And so if we've got our hypothetical pizza restaurant and we have one pizza oven, that is a fixed resource. That is not going to be variable. It's not going to change anytime soon without planning. And so we are in the short run production. So businesses actually produce in the short run. Long run, every resource is variable, meaning it is far enough in the future that anything is possible, meaning we could get a second pizza oven, we could grow big enough in the future that we have 100 pizza ovens in a huge regional distribution. We don't know. It's just saying it's far enough in the future that there are possibilities that anything could change, there's growth. Short run, we do have fixed resources. But big thing to remember, short run is where they actually produce. Long run is just a projection model. So these are all the different costs that you're about to start working with. And so the abbreviations are on the left. You've got the actual name of the cost on the right. So fixed costs, variable costs, total cost. Total cost is just fixed cost and variable cost added together. So if you take this and add it to that, you get that. So kind of like we had fixed resources and variable resources yesterday. Fixed resource was the pizza oven that didn't change with production. Variable resources were the dough and the sauce and the cheese that did change as you increase production. Fixed and variable costs work the same way. Fixed costs do not change with production. Rent is a fixed cost. That if you rent a building to start a business, well, whether you actually sell anything or not, you're still responsible for that rent. And so it's going to stay fixed no matter how much you produce or how much you sell. Your ingredients or your whatever you need to make or sell the product, those are going to be variable costs because as you produce more, those costs are going to go up. If we're making pizzas, as you produce more, the cost to buy more dough, more cheese, more sauce, more whatever, is going to go up as you produce more. So variable increases as production increases, fixed does not. If you put the two together, it creates total cost. Your per unit cost. And this is where I said yesterday we're going to not worry about average cost yesterday, but average cost becomes more important today. So the average fixed cost of production. You take the total fixed cost and divide it by the number that's been produced. That gives you an average fixed cost. If we have a total fixed cost of $100 and we produce 10 pizzas, it has an average fixed cost of $10 per pizza. Does that make sense? So average, you're just dividing by the total quantity. Same thing, average variable cost. You add these two together, that's going to give you the average total cost. Marginal cost becomes the big one. That marginal cost measures what is the additional cost of producing one more of something. If we produce one more pizza, what is the additional cost of just that next unit? And so this actually becomes a major thing going forward because when we bring in the concept of revenue, we're going to look for the point in the graph where marginal revenue is equal to marginal cost, meaning what is the additional money we can sell the next unit for, what is the additional cost that we sell it for. And as long as you're bringing in more money than what it costs to put out, then you're going to keep doing it. If it ever costs more to make it than what you can sell it for, you're not going to do it. And so that's kind of where we're headed with this. But you're going to get very familiar with these abbreviations. Well, you can write them out if you want to, but it gets real messy when you actually have to write all these out. So that's why these abbreviations are commonly accepted. If you put those abbreviations on the AP test, your readers are going to know what they mean. They're universally accepted. So it's much easier just to learn the abbreviations than it is to have to write out all of this every single time. So the breakdown to calculate these, so remember, fixed cost is not going to change with production. Rent, insurance, salaries, anything that whether you produce 1 or you produce 1,000, it's going to stay the same. If you want the average, well, take whatever the total fixed cost is and divide it by the quantity. That'll give you the average per unit. That's why we call those per unit costs. Same thing for variable. These are things that are going to change or your costs are going to increase as you produce more. you want the average variable cost, well, you just divide it by the quantity. Total cost, you put fixed and variable together. That gives you the total. If you want the average, once again, divide it by the quantity.
We're going to need to memorize these, or like
You'll learn them just through working hands-on with them. So it'll become a lot more familiar. All right, so marginal cost, like I said, this is the big one. And this calculates what is the cost of the next unit we produce. And so if it gives you the formula, the change in total cost divided by the change in quantity. So it says the production of 2 or more units of output increases total cost from 100 to 120. And this is a good example because typically, like I said, things are going to change one at a time. When you're first learning this, they're going to apply one more of something as you're looking for the change. But it is possible to change by more than one at a time. In this case, you've increased production by 2 units. The total cost increased from 100 to 120. So your change in total cost is 20. Your change in quantity is 2. 20 divided by 2. That would give you a marginal cost of 10 units for each of those next 2 produced. So it is possible to produce, or I guess increase by more than one at a time. But as you're learning this, we try to just do it one at a time because it's a little bit easier to grasp if we're only kind of keeping things steady. But College Board can present it more than one at a time, and then you got to plug it into this formula. So I would highlight that, circle that, because it is handy to know that if it ever changes by more than one, you've got to plug it into that. So these are our costs. Output on the left is the number we're producing. So if that's pizzas, 0 pizzas, 1 pizza, 2 pizza, 3 pizza, you get the point. Note that even at 0 units of output, if we don't produce anything, you still have to pay your fixed cost. If we rent a building to produce something, if we rent a restaurant to produce pizzas, but we never actually produce anything, we still got to pay that rent. And so even at 0 units of output, you still have a fixed cost. That becomes important down the line because typically they're going to ask you a question about that, where you've got 0 units of output, but you're still going to have to account, or they're going to ask you the difference between fixed costs and variable costs, and you have to know, even at 0 units of output, you still have to pay that fixed cost. So you can say, get the packets are up there. Just make sure you get all the sheets. All right. Variable cost increase with production. So you can see in that variable cost column, these are going to increase, 10, 17, 25. So as we produce more, variable costs are going to increase. Fixed costs stay the same, no matter how many you produce. If you want your total costs, add those 2 columns together. So 10 plus 10 gives you 20. 17 plus 10, 27. 25 plus 10 gives you 35. Your marginal cost is the change in total costs. So when we go from 10 to 20, the marginal cost of producing that first unit, that first pizza, was $10. When we produce a second pizza, the marginal cost of the second one was $7. Because we went from $20 a cost to $27 a cost. You produce the third one, the marginal cost of the third pizza was $8. The marginal cost of the fourth pizza was $15. The cost of what it's going to take to produce that next unit is your marginal cost.
So if we went from 10 to 27, why is it 7 and not 17?
Because this is your total cost. We were to produce that first pizza, the total cost was $20. To produce the second pizza, the total cost was $27.
Oh, so you're going down that line, not across.
Right.
Oh, okay.
So I'm going this way per unit. Marginal cost is always going to initially decrease, and then it's going to go back up. When we look at the curve, it's going to be like a Nike swoosh or a check mark. That initially, marginal cost is always going to decrease, and then it's going to increase, always. And when we start graphing this, there's a lot of shortcuts I'm going to show you as far as how to graph these. And so in a general sense, a lot of times you don't actually have to draw the points for the marginal cost curve. You just need to know that, hey, it's going to go down and it's going to go back up. You can just ballpark it, and that's good enough for what you're trying to show in the graph. All right, if we were to calculate the averages based on this table. So it says the average total cost of 6 units. Well, our total cost for 6 units is $120. Well, if we divide 120 by 6, what does that give you? Yeah.
Is it 12?
No, I thought you said 20.
No, I was doing it, yeah, 20,
Yeah,
yeah.
so-
I was getting there.
Yeah, a little early for simple math, but so costs $120 total to produce those 6 units. On average, it's $20 per pizza. The marginal cost of producing that 6th one was $50 is what it actually costs us, an additional $50 to produce it. But on average, each one of those 6 pizzas costs $20. Second one, average fixed cost of 2 units. Well, go to 2 units, go to your fixed cost. So it costs a total of $10, but on average, it's going to cost you $5. Does that make sense? Do we see what I'm doing there? Yes?
Wait,
No?
can you go over it again?
Yeah. Well, let's keep going down. So, well, what you have to do is, 1, it tells you how many units. That's the first thing you do, is go to how many units. Then it tells you which one you're looking at. So average variable cost is what we're trying to calculate. Well, if we go to variable cost, the 4th unit, so it costs a total of $40. But on average,
Oh, okay.
it's going to cost $10.
Okay. So you divide it,
Mm-hmm.
the 40 by 4,
Mm-hmm.
and then on the next one it's 60 divided by 5.
So average
If
total.
it was the variable one.
Yes, yeah. Okay. I see what you're saying. Yeah. So if we were to continue calculating average variable cost, then yeah, you would do 60 divided by 5, and so that would
And
give you 12.
if they wanted the average total cost of 4, you just do 50 divided by 4?
Where are you at?
Well, I mean,
Oh, here.
yes.
Yeah. So yeah. So if they wanted the average total cost for the 4th unit, or for all 4 of those units, then yeah, you would divide 50 by 4.
No, that's easy.
So here's the good thing about this. Once you learn how to calculate it, because really you're just figuring out where these averages are coming from. Because when I show you the graph in a minute, it's going to make more sense. Later on, you don't really have to do this a whole lot. You may have to do it a little bit here and there, but you're never going to have to calculate this whole table of numbers. That typically it's already given to you, but you need to understand how the averages are calculated from this table. And so that's what we're doing now. Is I just need you to know where these numbers are coming from when you see the graph. But anyways, to get the average, you just take the total, whatever it is, total variable cost, total fixed cost, total cost, and divide it by the quantity. That's going to give you the average per unit. And so marginal looks at the next unit. Average looks at all the units. So if we were to calculate all these out for all of those, so average variable cost, average fixed cost, average total cost for each of those 6 units. So if we were to calculate every one of those measures out, these are the numbers you get. Questions there? Does that make sense? That all we did is, 10 divided by 1 is 10. 17 divided by 2 is 850. 25 divided by 3 is 833. 40 divided by 4 is 10. That's all these are. These are the averages per unit for each of those 6 units. If we were to take these numbers and plot them and graph them, you get that. This is what we refer to as cost curves. All it is, all those curves are these numbers right here, the averages per unit plotted and graphed. Because it can be an intimidating graph because there's a lot going on there. But all it is these averages per unit plotted and graphed. And so if you were to have those total costs right there, you calculate the averages and graph them, those are your cost curves. Good thing is, very rare, you're going to have to draw parts of this graph, but you don't always have to draw all of it. And like I said, I'm going to show you some shortcuts to where really you don't even need the numbers. As long as you show the correct relationships between the curves, you're good. But I need you to know, that's what I'm saying, I need you to know where these numbers are coming from in order to understand how these curves are plotted. So what?
Kira's late.
Apparently.
Yeah, like,
Oh, tell them to go check in.
It's been in class for 20 minutes.
Yeah. Well, tell them to check in. So, marginal cost. As we said, it's going to go down and it's going to go back up. Marginal cost is always going to look like a Nike swoosh, check mark, something along those lines. It's going to go down and go back up. We're going to get to that. So, I'm going to explain the shapes of all the curves in a minute because then we get further into economics. But just in a general sense, even if you don't understand the concept, when you have to draw a marginal cost curve, it goes down and it goes back up. Just know that, because you're going to be able to draw, I would say, over 80% or answer 80% of the cost curve questions by drawing a simplified marginal cost curve, and then when we get to the average total cost curve, a lot of times those are the only two. But you don't even have to have numbers. As long as they look right, you're good. So, but marginal cost. Average fixed cost. All right, this curve slopes down and gets smaller and smaller and smaller and closer to the x-axis. If you worked with asymptotes, very similar concept. It's going to get smaller and smaller. It's never actually going to touch the x-axis. So, reason it gets smaller and smaller is because you're dividing by the same number over and over again. That if our fixed cost is $10, well, 10 divided by 1 is 10. 10 divided by 2 is 5, 333, 250, $2. And so that number is going to get smaller and smaller as you divide it by 10 as you increase that quantity. And so average fixed cost is just going to get smaller and smaller and smaller as you produce more. Another good thing is once we get a little bit further into understanding how these graphs should look, you don't have to draw this one anymore. And so eventually we'll get rid of it because you can find it elsewhere within the graph. Average variable cost. It's going to kind of have the same shape. It's always going to go down. It's more of a U shape than it is like a Nike swoosh shape. The marginal cost curve intercepts or crosses the average variable cost curve at its minimum point. So where the red line crosses the green line is at the green line's minimum point. Now I'm going to explain that in a minute of why it has that relationship. But in a general sense, you need to know that marginal cost is going to cross the average variable cost as well as the average total cost curve. It's going to cross both of them at their minimum point. All right, so blue is your average total cost. And so in a very simplified sense, red line crosses green line and blue line at green line and blue line's minimum point. Got that? And we're going to explain the technical theory and all that behind it in a second. But good thing is, once you get further into this, if you can draw that marginal cost curve, and then you can draw an ATC that goes up and out from the minimum point, a lot of times that's all you have to do. You just have to ballpark that graph, those curves. You don't have to plot points. You don't have to put it in any specific place. As long as you show the correct relationships and shapes of the curves, a lot of times you're good once we get further into this. But it helps you to understand why they're shaped the way they are, why they're located where they are. ATC is always going to be above a VC and AFC. So when we calculated total costs, we put fixed costs and variable costs together with our calculation. So fixed cost plus variable gives you total cost. If you were to add this curve, the black curve, to the green curve, it's going to give you the blue curve. So if we were to plot these points, these averages, these numbers are greater. These numbers are bigger than these numbers or these numbers. And so if we were to put these average numbers, well, and the way you're going to read this graph is that if you go straight up from any one of these numbers, where it hits these curves tells you the average cost for that unit. So remember, these are just plotted points for each one of these quantities. And so in a minute, we're going to draw a line straight up, and you're going to be able to calculate the different figures using this graph. But in a general sense, ATC is always going to be above the other two. Actually, it's always going to go in this order. Average total cost, then average variable cost, average fixed cost. Average total cost and average variable cost, these two curves are always going to get closer and closer together, but they're never actually going to touch. Reason being, if we were to subtract the average fixed cost from the average total cost, average variable cost will be left over. If we rearrange our order of operations, and so this gap in between ATC and AVC also represents the average fixed cost. And so the distance from there is the exact same distance from there to there, because that gap is your average fixed cost. Because if we were to add, average fixed cost to the average variable cost, it's going to bump it up to the average total cost. And so that's why we eventually get rid of this curve down here. We don't need it because we can calculate the fixed cost as the distance between average total cost and average variable cost. Because if we were to add them together, that's the difference. Or if you subtract average fixed cost from average total cost, it gives you the average variable cost because that's what's left over. How are we doing with that? Good? Okay. All right, like I said, those two, because as this gets closer and closer, if that gap is your average fixed cost, they're going to get closer and closer but never touch. You have to be able to show that relationship on a graph. That if it wants you to graph marginal cost, average total cost, and average variable cost without drawing average fixed cost, you've got to be able to show that these two are getting closer and closer together. Now, a lot of times it's just going to ask you a multiple choice question on that concept.
Can AFC go negative or
No. It's going to get smaller and smaller and minute, but it's never actually going to touch the x-axis.
no? Okay.
All right. So if it were to give you this graph, these cost curves, and it says calculate the total cost, the variable cost, and the fixed cost of the fifth unit. You're going to go to the fifth unit. I want you to draw a line all the way through the entire graph. Intercept every curve you can. And so you're going to find those intersections. But you're going to go up. If it says the fifth unit, go to 5 and go straight up through the graph, intersecting all those curves. They stop at marginal cost. I like you just to draw it straight through the graph, all the way straight up. That way it's a little bit easier to see. From these intersections, you go straight to the left, and that tells you whatever that cost is, the average cost. Meaning, so the average cost, or the marginal cost of the fifth unit is $20. Is what that tells us. So where it intercepts, that tells us the marginal cost is $20. Right? Average total cost. So the average of each one of these 5 units is $14. If you multiply those two numbers, then it's going to give you the total. And so $70 is your total fixed cost. Each one of those 5 units has an average of $14. Average variable cost. And all you're doing is forming these boxes within this graph. Because I'm going to show you in a second, these areas represent the different costs. But fifth unit, the average variable cost of 5 units is $12. The total cost of 5 units is $60. 12 times 5. Remember, these are telling you the averages. You just multiply it back out. That's going to give you the total cost for those units. And then for 5 units, the average is $2. So the total fixed cost is $10. Questions there?
Oh.
So everything in green is your total cost. So that area in green represents total cost. So we've got 5 units with an average of $14 a piece. The area in green represents $70 of total cost. In yellow is your variable cost. And this helps some people kind of understand it. So the yellow box is laying on top of the green box, meaning that the yellow is just part of the green box, but it's not actually separated. And so everything in green is your total fixed cost.
That's only on 5 units, though.
Yeah. And then everything in yellow is your total variable cost, representing the $60 variable cost of the total $70. And then down here is the area of $10 for your total fixed cost.
And that one's done on top of yellow and green.
Yes. The part of the green that you can still see also represents fixed cost. And so if we were to not have this AFC curve down here and it still wanted you to calculate fixed cost, you would find the difference. And so that the area of green you can still see is exactly equal to the pinkish red color down here. How do we feel about that?
Like, why is it like that?
Because if you were to add, well, let me go back up. So if you were to add this area in yellow plus that little sliver in green, then it's going to give you all that.
No, I mean, how does it happen that the little area between ATC and AVC equal the AF?
Because that gap between those two curves represents your fixed cost.
So that'll just always happen?
Yes.
Oh, okay.
Because you can calculate it out too. Like if you are more of a number person, so $2 is our difference there from 12 to 14 times 5 also gives you the total fixed cost of $10. And so literally you're just kind of piecing these boxes together. That if you can kind of break through everything that's going on and realize, hey, this is actually pretty simple, that you're just kind of calculating these different areas and putting them together, it's not that bad. You're just forming boxes within these graphs. All right, that's just telling you that that gap between ATC and AVC is your fixed cost. So that distance there is the same thing there. Because eventually, like I said, we'll get rid of the fixed cost curve more times than not. But you can always calculate the fixed cost as the gap between ATC and AVC. All right, we're not going to calculate all these by hand. So we've got our output 0 through 6. Our variable cost, we can see our total fixed cost is $20. Total cost, you put fixed and variable together, so 0 plus 20 is 20. Right there, we go 12 plus 20 gives you 32, 22 plus 20 gives you 42. Marginal cost is the change in total, so the change from 20 to 32 is 12. The change in 32 to 42 is 10. From 42 to 47 is 5. Note, these numbers go down, and then they go back up. That's that marginal cost Nike swoosh. It's going to go down. It's going to go back up.
Is that another thing? Why did the prices change? Or like, is that like that's not?
This is a whole different problem.
Okay.
Yeah, this is an entirely new problem we're about to look at. So, if we were to go through and calculate the averages for every one of these, well, it's not going to show me the numbers, but just to remind you, so ATC, average total cost is 6 units. Go to 6 units, go to the total cost, $120, divided by 6 gives you an average of $20 for each one of those 6 units. So $20, $20, $20, $20, $20, $20. Gives you $120. All right, these are our cost curves. So it says, how much does a 10th unit cost? So you're going to go to the quantity of 10. You're going to draw that line straight up through your graph, including go on through the marginal cost curve. Don't stop at it. Go on through it. It's not going to penalize you. And then form those boxes. So, marginal cost of the 10th unit is $25. So, we know already that the additional cost to produce that 10th unit was $25. The average total cost for each one of those 10 units is $20. So, how much is your total cost? So if we've got 10 units, and on average, each one of them costs $20, what is the total amount to produce it? $200. That's your total cost. So it costs a total of $200 to produce these 10 units, but on average, each one of them costs $20. Variable cost is an average of 15 per unit. What's the total variable cost? $150. So the total variable cost is $150. On average, each one of those 10 is $15. We're going to call it 5. The numbers are a little bit off. So the average fixed cost is $5. What's the total fixed cost? $50. If you add $150 of variable cost to $50 of fixed cost, that gives you $200 of total cost. If you find the difference between $15 and $20 represents $5, that's your fixed cost as well. So we could say, all right, the difference between average variable cost and average total cost is $5 from 15 to 20. Those $5 times 10 units still gives you a total fixed cost of $10. And so that is your fixed cost as well. So that box, well, everything in green is your total cost. That's your $200 of total cost represented in green. Your yellow is your total variable cost of $150. That's your total fixed cost of $50. Or the area you can see in green represents fixed cost as well. And so another example of how they could give it to you on the test. So what they want are the four corners of the box that represents the amount of the cost. And so it says that output Q, this is your output. It says what area represents total cost, variable cost, and fixed cost. All right, well, you go straight up. We can see that is our ATC curve. And so we know that's going to be a corner. And so we would say DQ0C, or however they put it, 0CDQ. That area represents the total cost. Variable cost. All right, you go up till you hit the AVC, which is that curve right there. You've got to pay attention to labeling. Say, okay, 0BEQ. So the area in pink is your total cost. That's your variable cost in yellow. So, two acceptable answers for fixed costs. What's one of them?
A is 0QF.
Yeah. So 0AFQ is one area, or BCDE. So if you find the area between variable cost and total cost, that's also an acceptable answer for fixed cost.
Why is that?
Because it's that subtracted, right?
So if you were to remove the fixed cost from the total cost, it leaves you with the variable cost.
Oh, okay.
And so that gap also represents the fixed cost. Cap?
Does it matter like what order the corners go in?
No, because typically this would be a multiple choice question, so you just got to find the right order to answer the question. But no, there is no. Typically they're going to start in the origin more times than not, but that's not a guarantee.
Oh my God.
So why are the curves shaped the way they are? Oh, this is the fun part.
Is it?
Yes, it'll be the best part of your day.
Why do you know why the curve?
Why? Because it's short?
Yeah.
Yeah, that way we don't forget it by tomorrow.
Yeah, I think it's just that kind of.
to explode.
Yes.
We don't want to know.
Yeah, I can see that.